All right, so we are on journal 69. I will say with this journal, there is going to be two parts. This is part 1. I'm going to show the other part in a different video here, and that's just because it would be a really long video if I put them all into one video. So I just split them up into 2 lessons. So in this bell work here, all I'm asking you to do is, given that list of number, there are 2 questions here, you need to find the mean and the range. So I'd pause this video now and try out the problems, and then come see your answer once you are done. Okay, so I'm going to work out the problems here. So if I want to find the mean, that's when I take the sum of my list of numbers. So if I were to add up all the numbers that are here, I would get 50. And then you take the sum and divide it by the number of terms you have. So the number of terms I have here are 5 terms. And same as this one, I have 5 terms here. So if I divide this by 5, I get 10. So my mean here is 10. If I want to find my range, that means I have to take my biggest number and subtract it by my smallest number. So my biggest number here is 30, while my smallest number here is -10. So that's going to be 30 minus -10. And 2 negatives make a positive. So that means that I'm going to add these 2 numbers. So that would make 40. 30 plus 10 gives me 40, and so my range here is 40, which makes sense because if my smallest number here is -10 and my biggest number is 30, well, going from -10 to 30, that's like adding 40. In other words, the range. They're about a 40 difference. So on this one here, if I want to do the same thing, I would just, do the same thing. I need to find my mean, so I'm going to start by doing that. So I'd add up all these numbers and, when I add up all these numbers, I also get 50. And I'm going to be dividing by 5 because there's 5 terms here. So that means my mean is also 10. But hey, wait a minute. These numbers here are they're not the same as these numbers here, but they got the same mean. Interesting. Let's see if their range is the same as well. So if I take the biggest number here, which is 12, and subtract it with the smallest number here, which is 8, I get 4. So my range here is 4. And yeah, sure, that should make sense because 8, to get to 12, I would have to add 4. So how is it that I got the same mean but different range? Well, something you should be asking yourself is, how spread out are these numbers, right? So take a look at this list and then take a look at this one. How are they different? How far spread out are the numbers compared to each one? Well, when I look at this one here, you might notice that the numbers are apart by about 10, right? -10 to 0 is about 10 apart. 0 to 10 is about 10 apart. So versus this one here, where the numbers are about 1 apart each, right? 8 to 9 is about 1 apart, 9 to 10 is about 1 apart. So if I had to choose which one was more spread out, it would be this one, which explains why the range here is bigger because the numbers here are more spread out. Whereas this one here is a smaller range value because the numbers aren't as spread out. So that is what we're going to focus on in today, is talking about how spread out a data is, or what we call measuring dispersion. So we're going to talk about how you can measure dispersion in a data, and there are multiple ways you can do it. One of them is using range, but sometimes range doesn't really give us a clear picture of our entire data, but more on just the biggest number versus the smallest number. So what if we want to check each data in between, right? All right, so that's what we're going to be talking about next in the next slide. Okay, so before we get started on this slide, I don't want you guys to be overwhelmed by these formula. I promise you I'm going to break these down and make it a lot easier to use and understand, and it really isn't that hard to use. But before we get started, let's talk about what measures of dispersion is. That is about finding how spread out your data is. And we can do it in 3 different ways. So one way, we've already talked about it, is using range, but range really only looks at the smallest number and the biggest number and how far apart they are. But it doesn't really talk about the numbers in between. So we need some sort of math or calculation here to help us figure out what the overall spread of the data is. And that is using something called standard deviation. However, in order to figure out what the standard deviation is, you have to first figure out what the variance is. So I like to think of the variance as the stepping stone to finding standard deviation. So here's how things work. Variance is basically finding the average of the square difference from the mean. Okay, so those are just fancy terms for saying, well, I want to know how far each point is from the mean, and when I find it all for each point, I want to take the average of that point. Okay, so in order to do that here, we calculate something called the variance. So let's break down what this formula means. Let's start with inside this parentheses here. So this x value here is what we call, or what is each data point, okay? So you would plug in each of your data point or each of your value into this x. Now, let me just say this x is different from this x. This x here, you might have noticed, has a line above the x. That is significant. Anytime you see a line above the x, that actually represents the mean. So an x with a line above it represents our mean. So what is this saying here? Well, it's saying that I'm going to take a value or a number on my list and subtract it by the mean, because what that allows me to do is find the distance between one data point towards the mean. And then afterwards, you want to square it. And I'll explain why later, why we would square it. Okay, then this n down here is your number of terms. So how many terms are there, or how many numbers you have on your list. And then this E, this weird looking E here, if you remember, that's sigma. And the thing is, in Greek alphabet, this is what we call the capital or the uppercase version of sigma. Whereas this guy here looks kind of like a O, but it has kind of like a stem that kind of pops off of it. So you can write it like this, almost like a 6, but I don't like to write it that way. I actually like to write it more like this, like an O with like a cursive like tilt to it. So I usually write it like this, and that represents sigma, but the lowercase version, okay? So these are both called sigma, but this is just a lowercase version. So when you have sigma squared, we can is usually represented as the variance. So sigma squared is what we call the variance. What else did I want to mention here? So whenever we're talking about the uppercase sigma, we also call it the summation symbol. And so if we're having a summation symbol, that means we're going to add up each term. We're going to sum up each term. So you'll see that later. Now, when you just have sigma by itself, so notice how this sigma is just like to the first power, there's no square here. That represents what we call the standard deviation. And by the way, standard deviation is really what we care about. Anytime you're trying to figure out how spread out a data is, you're looking for standard deviation. The variance just is a formula that helps us get to standard deviation, but standard deviation is the value that we really care for. And so what you have to do is take your variance. Notice how the variance is sigma squared, and so this here is your variance, and you take the square root of it. So if you want to find standard deviation, you take the square root of your variance. Here is also another formula you can use. It's just the same as this, but it's only using words. So basically take the square root of your variance and you'll find your standard deviation. That just stands for standard deviation. Also, I like to mention, so standard deviation is what we call the average distance from the data point to the mean. So you would calculate all the distance from each data point to the mean and then take the average of that, and that there is your standard deviation. So we're going to do an example problem next, doing it for part A and for part B that you saw in the bell work. All right, so in part A, I'm just going to rewrite that list of numbers that you guys saw in the bell work. So it was -10, 0, 10, 20, and 30, I believe. Yeah, because it was like, I believe it was 5 terms. And then the mean we calculated, because we're going to need that to calculate our standard deviation, was 10 here. So if we want to calculate the standard deviation, we need to first start by finding what we call the variance. So the first step is to find the variance. Now, in order to find the variance, that's this formula here. I'll just write it up above. So the variance is the one that's sigma squared, and it's taking the sum of your data point subtracted by the mean squared over the number of terms. So in this case here, I want us to just focus what's inside this parentheses here. So notice how this formula has parentheses. Well, that means that I am going to need parentheses. So I'm going to make some parentheses here. And this x here represents each value from the list. Well, here I have 5 terms. So I'm going to start with the first term in my list, which is -10. That there is a value on my list, and I'm going to plug it in for the x. So that means I have a -10 minus, because there's a minus sign here, and this symbol here, the x with the line above it, is the mean. Well, what is the mean for this list? It's 10. So that means I'm going to be subtracting it from 10. And notice how this outside parentheses here has a squared. So I'm going to need a square here. Let me do that in black. And that means now I have the first term where I'm taking the data point, subtracting it by the mean, and squaring it. But I need to do this for all the data points. So the next set of parentheses, I'm going to do the same thing, but now I'm going to use the second term, which is 10. So this is going to be 10 minus the mean. The mean didn't change. It's still 10 squared. And then I would do it for the third term. So the mean here did not change. And now my third term here is 10. So 10 minus 10 squared. My fourth term here is going to be 20 minus 10 squared. And then my fifth term here is going to be 30 minus 10 squared. And because we have a summation to the side of this here, we are adding up each of these terms. So I need plus signs in between. And then I would divide it by the number of terms I have. Well, the number of terms I have is 5. And so from there, I'm going to just try to simplify this. So to simplify, I'm just going to first start with simplifying the inside of each parentheses by subtracting the numbers. So if I take -10 subtracted by -10, I get -20 squared. If I take 0 subtracted by 10, I get -10 squared. If I take 10 and I subtract it with 10, well, that's just 0. That's nice. 20 minus 10 gives me 10. And last but not least, 30 minus 10 gives me 20. So I have 20 squared, and this is all over 5 still. And so now what I'm going to do is I'm going to square those numbers here. Now, let me just give you a fair warning. When you square a negative number in the calculator, make sure you put parentheses around that negative as well. Just the way it looks right here. Yeah, when you type it in the calculator, make it just like how it looks. So parentheses, -20, close that parentheses, square it. Because when you take two numbers and you square it, when you take a number that's negative and you square it, That's like multiplying two negatives, which makes a positive. So if you take negative 20 and square it, you get 400. If you take negative 10 and square it, you get 100. 0 squared is 0. 10 squared is 100. And 20 squared is 400. Divide that all by 5. Now, if you add up all the terms here, you're going to get, so in the numerator here, you're going to get 1,000 divided by 5, which is, if you take 1,000 divided by 5, you get 200. So that means our variance here, or sigma squared, is equal to 200. So this here is my variance. Let me spell that correctly. All right, but that's just part one of finding standard deviation. So I found the variance, now I can go ahead and find my standard deviation. All right, so if I want to do part two, which is to find the standard deviation, I need to take my, my variance to do it. So standard deviation is taking the square root of the variance, so sigma squared. So if I take the square root of this guy here, see if I can make this smaller and put this, yeah, there we go. So if I can take the square root of that, that's going to be the square root of 200. So the square root of 200 is, let me double check here, I'm going to use my graphing calculator to do it, is 14, I'm going to round to 2 decimal places, so 14.14. So our standard deviation here is 14.14. So this is our standard deviation. I just want to mention something here. So let's talk about why this formula came about. So if you have these data points, you had to take each data point and subtract it from the mean. Every time you do that, you are calculating the distance for that data point from the mean. But why do we square the number? Well, that comes down to what happens when you square a negative and a positive number. So when you square a negative number, you always get a positive number, right? And when you square a positive number, you always get a positive number. So no matter what's inside the parentheses, when you square it, it will always be positive. Well, the reason why we need that is because we are calculating distance. So distance, in at least math, is not a negative value. Distance is always a positive value. So the squaring allows it to be a positive number. But here's the thing, when you square something, it gets bigger, right? And that's not good. That doesn't make our numbers accurate. So that's why variance alone is not a valid number to use. That's why standard deviation is the square root of variance, because to undo the squaring that we did, we have to take a square root. We learned long ago that square roots undo squaring. And so standard deviation takes the square root so that we can get the actual number for the average distance from each data point from the mean. So that's how the formula came about. Now I want you guys to think, if this list is the one that you guys said is more spread apart, and you got this as your standard deviation, when we try to find the standard deviation for part B that was less spread apart, do you think the standard deviation is going to be smaller or bigger? So hopefully you answered the question as it's going to be smaller because part B is going to be less spread apart. So let's go see if that's true or not. All right, so since we have a little bit of more experience finding variance, I'm just going to rewrite that variance formula up here so that way I can see what it is and refer back to it. But yeah, since we have a little bit of experience this time around, let's go ahead and we'll probably be able to find the standard deviation a little bit quicker this time. So that list in part B, I think, believed to start at 8 and ended at 12. And so there are 5 terms here, and the mean was also 10. So now what I'm going to do is first always find that standard, the first step is always to find the variance first. So if I want to try to find the variance, I need to make my parentheses and so that I can plug in each value. Now, since I have 5 terms here, again, I'm going to need 5 sets of parentheses. So I'm going to go ahead and make that first. And they're all going to be squared because the formula squares them all. And my mean here is 10, so I'm going to write a 10 in for each one, and the mean is always on the right-hand side. So that's why I'm writing all of the parentheses, the mean on the right-hand side. Now, in the first parentheses here, this is going to be the first term, which is 8. Second term is 9. Third term is 10. Fourth term is 11. Fifth term here is 12. And so now we're going to subtract the numbers because, we're trying to find distance, so you want to subtract. And so from here, I need to put my plus signs between each parentheses because that means that I'm summing up all the terms, and I have this summation symbol here, so I want to sum up all the terms. Then we want to divide it by the number of terms we have, which is 5. And so from here, I'm going to now simplify. So 8 minus 10 is negative 2 squared. 9 minus 10 is negative 1 squared. 10 minus 10 is 0. 11 minus 10 is 1. 2 minus 10 is 2. It's over 5. Okay, so negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 2. 2 squared is 4. So this is my numerator divided by 5. If I add up all the terms in the numerator here, I get 10. 10 divided by 5 is 2. So my variance here, or sigma squared, is equal to 2. So this here is my variance. And so now if I want to figure out what my standard deviation is, I would have to take the square root of 2. Now notice how the variance here is already a lot smaller than before. So if you remember the variance from before, it was 200 compared to this one here, which is only 2. So we're going to find that standard deviation. And so that's taking the square root of 2, because that's our variance here. And that's going to give us, if I put this in the calculator here, the square root of 2 is 1.41, if I round to 2 decimal places. And so here is my standard deviation. Now, I do want to mention, when you look at this one here, it's about 1.41, whereas the other standard deviation was 14.14, which is a big difference, right? So we can obviously see when there is less spread, like the numbers are less far apart from each other, you're going to get a smaller standard deviation. So that's what standard deviation does. It helps us find the average distance between each data point from the mean so that we can figure out how spread out is our entire data compared to the mean. All right, so I hope that helps you out here with finding standard deviation. You'll be needing to do that for your project. Now keep in mind, I did it for 5 data points. You will need to do it for at least 20 data points, okay? The minimum data points that you need is at least 20. All right, so I hope that helps you with your project. Oh, one last thing I do want to add. When you do this in your project, I need to see the work that you calculated your standard deviation. So please show your work when you're calculating the standard deviation. I don't want to just see the answer.